The next type of FRQ that we need to be prepared for is position, velocity, and acceleration type problems. So do a quick review before we start. So if you have a position function x of t, now it could be s of t, y of t, it could be anything. We're just using x of t. The velocity is the derivative of the position. Now this should make sense because it's a change in position over change in time. If your velocity is high, your change in position is going to be large. So you get a large velocity. So how fast your position is changing is known as velocity. Now this has a direction, positive and negative, so one way or the other. And then to get to acceleration, acceleration is how fast your velocity is changing. So if your velocity increases very quickly, that means you have high acceleration. So the change in velocity over change in time is high. So that should make sense. So how do you get acceleration? It's the derivative of the velocity, or the second derivative of the position, because the first derivative is also velocity. So in order to move downwards in this chain, you take the derivative, but to go backwards, you take the antiderivative. You integrate to go backwards in the chain. But remember, when you integrate to go backwards, you're going to get a plus c. Don't forget that. All right, so we have an example here of a velocity. And I want to get a concept across here. My axes aren't very dark. Let me darken them in here. There's my x, or my t, I should say, my time, and that's my velocity. And so you have positive velocity, so it's moving to the right for that portion. Now it stops here because the velocity is 0. And now the velocity is negative, so it starts to move to the left. It stops again because the velocity is 0 there. And now it starts moving back to the right, speeds up, slows down, and stops again. So visually, you should be able to see what's going on. Now I'm going to make up some numbers. I'm going to say the area of this top one is 50. And the area of the bottom piece is 6. And the area of this top piece here is, I'm just going to make up a number, 45. I don't know what it is, but I'm making up numbers. We're going to call that point A, call that B, call that C. So you need to understand the difference between displacement, change in position, and total distance traveled and how they are related. So if you integrate the velocity, I'll go from 0 to A, you would get 50. Now remember what velocity is. Velocity is the rate of the position. And remember from our accumulation section, when you integrate a rate, it gives you the change in what it's the rate of. So if velocity is the rate of the position, that means the position changed 50. It moved 50 spaces to the right. Okay? That's known as change in position. Whoops. Change in position or displacement. Displacement is how far it's been displaced. So let me do the same thing, but I'm going to go from 0 to B. And that's going to be 44. Why 44? Because integrals, it's net area. So I am going to take the area above minus the area below. 50 minus 6 is 44. So what is this saying? Remember, this is x prime of t. When you integrate the rate of position, it gives you the change in position. So the position changed 44. Why is it 44? Well, think about it. It moved 50 spaces to the right and then 6 spaces to the left. How far are you from where you started? 50 minus 6. So you've been displaced 44 spaces to the right, or your position has changed 44 spaces to the right. Okay? So when you integrate a velocity, it gives you displacement or change in position. Now, if you want total distance traveled, that's a different story. Because in this example here, we went 50 spaces to the right, then we moved back 6 spaces to the left. You should think your total distance is 56 because you want to add that to your distance traveled. So how do we add this instead of subtracting? We need to make it positive. So you can't have any negative velocities. So total distance has a special formula. You just integrate the absolute value of the velocity, and that gives you total distance. So if you were to do that, here you would get 56 because the absolute value takes any negative values and makes it positive. And so the integral from 0 to b would be 50 plus 6, or total 56. So here's the difference. When you have an absolute value on your velocity, that's going to give you total distance traveled, not displacement. But when you just do velocity alone, it's going to give you displacement or your change in position. And again, tie that into accumulation, and this is all fundamental theorem. If you integrate x prime, it tells you the change in x. X is a position, so your position changed 50, or you're displaced 50. In this case, 44. But that's different from total distance traveled. The next concept you'll see in these questions is about the speed increasing or decreasing. A common mistake that people make, they'll take a look at the acceleration, and they'll say if the acceleration is positive, the speed is increasing. If the acceleration is negative, the speed is decreasing, but that is not correct. So I'll give you an example. Suppose your velocity is positive. That means you're moving to the right. And let's suppose your acceleration is positive. That means you're accelerating to the right. Well, it makes sense that if you're moving to the right and accelerating to the right, your speed is going to increase. Okay, let's do another one. This time your velocity is positive. That means you're moving to the right. But if your acceleration is negative, that means you're accelerating to the left. Now think about this. If you're moving to the right, but you're accelerating to the left, clearly you're actually slowing down. So that in this case, your speed is going to decrease. Okay, we have 2 more examples we're going to do. The next one, if your velocity is negative, so we'll say you're moving to the left. If your acceleration is positive, that means you're accelerating to the right. Well, if you're trying to move this way, but you're accelerating the opposite direction, obviously you're going to slow down and your speed will decrease. In the last situation, when your velocity is negative, so we'll say we're moving to the left, and your acceleration is negative, so you're accelerating to the left. Now think about this. If you're moving left and you're accelerating to the left, you're going to increase your speed. So you'll say that your speed is increasing. So when is your speed increasing? The first case and the last case, and it happens when your velocity and acceleration are both positive, or if your velocity and acceleration are both negative, or in other words, they have the same sign, and that will be your justification. When is speed decreasing? The middle 2 cases, speed is decreasing, and those both happen when your velocity and acceleration have opposite signs. So that's going to be your justification for speed decreasing on these problems. All right, let's go ahead and start doing some examples. All right, this is the 2017 number 5 question that deals with position, velocity, and acceleration. So as we read, 2 particles travel along the x-axis or moving left and right from 0 to 8. The position of the particle is given by, so we have the position of the first particle P, and the velocity of particle Q, we have the velocity of the other particle, and they tell us the particle Q is at position 5 when t equals 0. So the position of particle Q is 5 when time equals 0. So I've summarized all the information and boxed it. So we're done with that. So part A, when is a particle P moving to the left? Well, when is something moving to the left? When its derivative is negative. Or excuse me, when the velocity is negative. Okay. Now you can think about this in like if the position is decreasing, it's moving to the left, because decreasing, it's getting smaller. So when the position is decreasing, how do you know if x is decreasing? When its derivative is negative, but the derivative of position is velocity. So you can think of it that way. It all comes back together. But we need the velocity of p, but you need to tell me, the grader, how you get the velocity. And you have to tell me it's the derivative of the position. So this is very important, that you tell me how you get the velocity. You need to explain that. So here it's ln of a function box. So this is ln of box. What's the derivative ln of box? It's 1 over the box times the derivative of the box, which is 2t minus 2. All right. Now, this simplifies. I'm going to factor the 2 out. The bottom does not factor. In fact, if you plug in values between 0 and 8 into the bottom, it's always going to be positive. So here's one thing. If you look, this doesn't factor nicely. You can try things 2 and 5, minus plus. That's going to get you a minus 3. That's not going to match up. And so I guess you could try like quadratic formula if you wanted. So I will just, let me throw out quadratic formula real quickly and just show you. Negative boy, couldn't decide, go radical party, so squared, he missed out on 4. Awesome. Cookies, 2 a.m. So you get 2 plus or minus square root, and that's 4 minus 40, negative 36 over 2. This is imaginary. This has no real roots. That means it never crosses the x-axis. Never, ever, ever crosses the x-axis because there are no real roots. So therefore, it's either always positive or always negative. Let's plug in 0, and you get positive 10. So you can conclude the bottom is always positive. So the only place where v of p could change signs is where the numerator equals 0 or t equals 1. So that is your only possible place where it could change directions. So we're going to make a nice sign chart for the velocity in the p direction. So this is how you show work. You need to show that you tested the velocity at different points. So if you plug in 1/2, 1/2 minus 1 is negative. The bottom's always positive, so that's going to be negative. Plug in 2. 2 minus 1 is positive. The bottom's always positive, so it's going to be positive. So the question is, when is it moving to the left? Between 0 and 1. Whoops, didn't mean to do that. Between times 0 and 1. So we'll state that. The particle P is moving to the left Now, you could say on the interval, and put a 0, 1, because, or you can say from between t equals 0 and 1. I mean, there's a lot of ways you can state it. As long as you convey the idea, it's in the interval from 0 to 1. So I like the interval notation. How do you know I'm not saying at the 0.01? Because in the context it says on the interval, so when I place that, you should know it's from t equals 0 all the way to t equal 1. There's a lot of ways, but you have to give a justification why, and you have to say because Vp of t is negative on that interval. Okay, so that is all that's required. You need to give the justification. If that's not given, you're not going to get full credit. I need a justification why you decide it's moving left on the interval. This table is necessary that you found when it's moving left, when it's moving right. The derivative was necessary, saying the derivative is the velocity. Okay, so for part B, they're a little nicer. You already have the velocity for part B. And they want to know when the particles are traveling in the same direction. So you know the first one is going to the left from 0 to 1 and to the right from 1 to 8. Now you have to find out Q. What's happening with Q? This is given as t squared minus 8t plus 15. That is nice and factorable. T minus 5, t minus 3. And again, for an object to change directions, it has to stop. So you want to know when it equals 0 and test all the regions around that. That's going to come out to be 3 and 5. So we're going to make a table just like we've done before and find out what the velocity is at points around 3 and 5. This is time. This is a velocity in a q direction. Plug in 1. 1, 1, negative, negative makes positive. Plug in 4. Negative and positive make negative. Plug in 6. Positive and positive make positive. And there's my sign chart. But I'll tell you a secret. You know this is a parabola. You know it crosses the x-axis at 3 and 5. Knowing those two things, and it's a parabola, you knew ahead of time it's negative between 3 and 5. So you could have made the sign chart without even testing numbers, just by knowing, okay? But you need to show the sign chart to show the grader that you found out where it's positive and where it's negative. So here's the question now. In what regions do they have the same sign? From 0 to 1, this is moving left. But 0 to 1, this is moving right. No bueno. From 1 to 8, this is moving right. Okay. So 1 to 3, they're both moving right, and 5 to 8, they're both moving right. So it's going to be 1 to 3 and 5 to 8. So you would say both particles are moving the same direction. And again, there's many ways you can state it. I'll just do it differently this time. For t, okay, for t between 1 and 3, so 1 to 3, they're both positive. And the other region was 5 to 8, right? Because 5 to 8 is positive, 5 to 8 is positive. Reason? Because VQ of t and VP of t have the same sign, SIGID sign, on those intervals. So you have to express that the velocities are both positive or the velocities are both negative on those regions. All right, so that's part B. Kind of tedious, not difficult, but tedious. Part C, find the acceleration of particle Q at time t equals 2. So acceleration of particle Q, you have to tell me how you're going to find it, okay? don't just tell me what it is, you have to show me how you're going to find it. And you should know acceleration is the derivative of the velocity. So you're telling the grader, oh, I take the derivative of velocity. So I take the derivative of that, and I get 2t minus 8. So that's the first step. Then we want it at what point? T equals 2. So then you tell your grader the acceleration of particle q at 2 is 2 times 2 minus 8, negative 4. Okay? So now I've found the acceleration. And now, is the speed of the particle increasing or decreasing? This is what I explained earlier. If the acceleration and velocity have the same sign, then the speed is increasing. If the acceleration and velocity have opposite signs, the speed is decreasing. So I find the velocity at 2, which will be 2 squared minus 8 times 2 plus 15. But that's going to be positive. So I found the velocity, and that is positive. I found the acceleration, that is negative. So therefore, the speed will be decreasing, right? So I make that statement. This is part C. The speed of particle Q is decreasing at t equal 2, and you have to give a reason, a justification. Because AQ of 2 and VQ of 2 have opposite signs. That is part C. And then part D, find the position of the particle Q the first time it changes directions. So looking at our previous work, particle Q changes directions at 3. Okay? We find that from B. So we want to find, what is it? The position of particle Q at 3. So part D, we want the position of particle Q at 3. Okay, so do we know the position of particle Q at a specific time? Yes, we do. If we look up here, we have at time 0, the position's 5. We have Q sub 0. So, x Q sub 0. Now, what do we do with that? Well, this is like accumulation. How much position did I have at time 0? Well, if I want the position at 3, I got to find out how much the position changed from 0 to 3. How do I find that? You integrate from 0 to 3 x prime q t dt. Or in other words, you integrate the velocity to get the change in position. And just like we've been doing, this is fundamental theorem of calculus. This is something you've been doing with accumulation. You take your starting amount plus the change in x to give your final x. Well, what's the starting? I believe it was 4, wasn't it? Oh, 5. Bad, Yoshida, bad. 5 plus x prime q, which is VQ. Where's VQ? Okay, so we want to integrate from 0 to 3 t squared minus 8t plus 15 dt. And I have to do that by hand. So it's going to be t cubed over 3 minus 8t squared over 2 plus 15t from 0 to 3. And then I'm going to get, plug in 3. 3 cubed over 3 minus 8 times 3 squared over 2 plus 15 times 3 minus, then I plug in 0, and I'm going to get 0. Done. You don't have to show any work. Take that back. You don't have to simplify this. that answer is sufficient. You don't have to do anything to that. Yeah, that's it. Now, if you did happen to simplify this, it comes out to be 23. And that is the first FRQ. Let's do one more, the 2018 one, and we'll see how this one works out. All right, for 2018, let me get my guidelines up here real quick so I don't lie to you guys too much. This is number 2. Hopefully this one is less work. Oh, and this is a calculator problem. So go ahead and bust your calculator out. I'm not going to be showing you the calculator work. You're going to have to do that on your own. If you have problems with that, come and ask me questions. But I'm going to plug these equations in real quick. 10 sine 0.4 t squared all over x squared minus x, whoopsies, x squared minus x plus 3. All right, I have my v of t in there. So program that v of t into y1 on your calculator. Make sure you're in radian mode, and everything should work out fine. I'm going to quit, and let's get some basic information here. So we know that x sub 0 is negative 5. I'm going to move it down below. X sub 0 is negative 5. So I just took this and transferred it here. Wow, this one's pretty easy. I like this question. I think we're going to get through it quickly, hopefully. A, find the acceleration. Again, you need to explain to the grader how you found acceleration. If you don't write this, you'll be very sad because you know how to do it, but you didn't show your work. I take the derivative of v and plug in 3. That you're allowed to do on your calculator. So plug that into your calculator, and you get approximately negative 2.118 done with part A. But again, if you don't have this, you will not get full credit because you did not tell the grader how you found acceleration. There's nothing here about acceleration. You need to tell the grader, I took the derivative of the velocity. Very important. Part B. Find the position of the particle at t equal 3. So we want the position at 3. Well, you have to take the starting position. Look at that. We know the starting position. That's x sub 0. We need to know how much the position changed. Remember, when you integrate velocity, it gives you the change in position. You integrate velocity, it gives you change in position. I want to know how much the position changed from 0 to 3. Because if I know where it started and how much the position changed, or the displacement, that will give me the final position. Well, x sub 0, I've already defined as negative 5, so it's as if I put a negative 5 there, but I will rewrite this for you. Doesn't take much effort. Again, you pop this into your calculator. If you do this, you should get negative 1.760. So that's going to be the position at time t equal 3. All right, let's just keep on rolling because this is going very quickly so far. C, evaluate the integral from 0 to 3.5 of v of t. Okay, again, just pop that in the calculator. You do that in your calculator, and you'll get about 2.844. If you round off or truncate, you'll get a 3 there instead of a 4 at the end, but either way is fine. Then they want us to evaluate with the absolute value. So if you don't know how to do that in your calculator, it's math. To get to absolute value, you do math and then right arrow, and then 1 is absolute value. So that's how you access it. I'm not going to actually show you on the calculator, but whoopsies. Pop that into your calculator, just as it looks here, and you'll get an answer. It's going to be 3.737. So that means the position changed this much, but the total distance traveled is that much. Okay? And then it says, interpret the meaning of each integral in the context of the problem. So the first one, you could say the displacement or the change in position, however you want to say it. So you can say the position of the object changed this many units, from 0 to 3.5. Do we have time? Is it seconds, minutes, hours, days, miles, meters? We have nothing. Okay. So for the first one, you could say the position. Where's my T? I don't know how to write. The position, or you could say the displacement of the particle changed the integral from 0 to 3.5 v of t dt from t equals 0 to t equal 3.5. So you could say it that way. You could say the particle was displaced this much, if you want to use that word displaced. The position of the particle changed, or the particle changed positions by this much. A lot of ways, but that's the general concept. And for the second part, it's a total distance traveled. The particle traveled a total distance of that much from t equals 0 to t equal 3.5. Okay, so pretty straightforward problem. The difference between displacement and total distance clearly seen there. And part D, a second particle moves along the x-axis, position given by that. What time t are the two particles moving with the same velocity? So you would say v2 of t, I'm defining v2 of t as the derivative of x2 of t. Okay? v of 2 of t is the derivative of x2 of t, which is, and this, what number is this? Number 2. Okay, I need to find this. So that's going to be 2t minus 1. So first I have to find the velocity of particle 2. And then I want to know when this velocity equals the velocity of particle 1. So now I would say v of t equals v2 of t at. Now on your calculator, you would graph both your original velocity and the v2 that you just found. So you put this in as y2. This is already y1. This is y2. And you want to know when they're equal, so you find their intersection. If you find their intersection, that's your answer. At t equal 1.57054. And that was very quick and easy. And that is position, velocity, and acceleration.